we're ready for page 2 of the 7-2 notes. We're going to look at one more example of graphing a line with some information, and then we'll talk about a standard form and something called point-slope form. So this example should be pretty simple. We're asked to graph a line which has a point here and a slope, -2, -2. Well, that's half the battle is having one point, right? So let's plot that point, -2, -2. And then the slope is 0. So what does that mean? Hopefully you recognize that the slope of 0 means it's a horizontal line, right? We don't rise at all. We can think of this as 0 over whatever, and we can run however far we want. So we can run however far we want, this way or this way. Maybe I'll run all the way out to here. Why not? And then we can connect those points, and that gives us our line. Now, as an extension here, if you wanted to know how we would write this equation, so how would we write this equation in slope-intercept form? Well, what is the intercept? The y-intercept looks like it's -2, doesn't it? And the slope is 0. So if we have y equals mx plus b, if the slope is 0 and the y-intercept is -2, we'd have y equals 0, x minus 2, right? But 0 times x is 0, so that part really goes away, and we just get y equals -2. So your slope-intercept form would actually cause the x to go away in this case, and it's a special case because it's a special horizontal line. Okay, so we have a couple other forms of equations of lines. You might like slope-intercept form, which is this guy, right? But we have a couple others that are useful in other ways. Standard form, which we've seen examples of already, has the form ax plus by equals c. Okay. Now, a, b, and c are all constants. There is another special requirement, a couple special requirements. So a, b, and c are integers. Okay, that means there are no fractions or decimals, so they're integers. And a needs to be non-negative. So a is greater than or equal to 0. Alright, so we can't have a negative a value. So we're going to practice finding equations in this form here in just a little bit. And we'll refer back to these requirements here as we do that. There's another form that's very useful as well. It's called point-slope form. Okay, point-slope form is y minus y1 equals m times x minus x1. Now in this form, m is the slope still, and x1, y1 is a point that the line goes through. This form is very handy when you're finding equations of lines if you're given 2 points, or if you're given a slope and a point. Okay? So we're asked in these next few examples to find equations of lines where we're given a point and a slope. Now, it would make sense if we're given a point and a slope to use point-slope form. Now we're asked to write in our equation in standard form though. So what we usually do, what I like to do, is to start with point-slope form, so find this guy first, and then manipulate it until we get to standard form. And so I'll walk you through that process with these few examples here. So we're given a point, we're given a slope. So the point I'm going to let be my x1, y1. And the slope, of course, is m. And I'm going to plug those into point-slope form. Okay? So I have y minus 4, which is my y1, equals our slope, -3/5, times the quantity, and again I'm using this form here, x minus x1. So x minus a negative 3 would be x plus 3, right? Okay. So we have this, but this is an equation of the line, but it's not in standard form. Now, you might think it's kind of ugly and nasty, so we try to make it look prettier, basically. So if we want to get this to standard form, which we're asked to do, first thing I like to do is to distribute the negative 3/5. So get the negative 3/5, get the parentheses gone, basically. So if I distribute the negative 3/5, this becomes y minus 4 equals negative 3/5 x. And negative 3/5 times 3 would be a negative 9/5. Now, if you're not great at fraction computations in your head, you could use a calculator. If you have one that has good fraction capabilities, that would be very useful in this section and, in fact, in this class. I like the TI-30X2S. So if I'm not very good at fraction computations, I could do, what is it, negative 3/5. So I want to show you something here. So negative 3, this is the fraction button, the ABC button. So negative 3/5. And I'm going to multiply that by 3, right? And your calculator may give you a mixed number, which is not very useful. In most applications, it's hard to work with them. But there's a feature on these calculators that will change this to a improper fraction for you. That same ABC button, if I hit second and the ABC button and then hit enter or equals, it'll change it to negative 9/5, which is a much easier fraction to work with. So I suggest use improper fractions. If I have negative 1 4/5, that's harder to work with. So anyway, I have this, and it's still not in standard form, and it's not even in slope-intercept form, is it? So the next thing I like to do is to get the y by itself. Okay, so I'm going to add 4 to both sides. Add 4 to both sides. Alright, so again, I'm going to add 4 to negative 9/5. Well, for me, I can do this in my head, but you could use a calculator, negative 9/5 plus 4. 4, I also know 4 times 5 is 20, so 4 is 20/5, right? So this should be y equals negative 3/5 x. And then 4 is 20/5. 20/5 minus 9/5 would be 11/5, right? Or 20 minus 9? Yeah, so plus 11/5. Now, again, I could use my calculator to do this. I have my negative 9/5 there already. I'm going to do plus 4. And it will probably give me a mixed number. And I know it gives me an improper fraction, so 11/5. Alright? So it gives me 11/5. If it did not, for some reason, if it gave me a mixed number, I could change it. In fact, I can change it to a mixed number if I want to. Do second, the ABC button, and gives me 2 1/5, right? If I want to change it back, the second ABC button, improper fraction. Alright. So let's see what I have here so far. So I started, this is my point slope form. Started with that. I worked my way to this guy, which this is slope-intercept, right? We have y equals mx plus b, that's slope-intercept. But what I want to get is standard form. And standard form has all the x's and y's on one side. So I'm going to add the 3/5 x to both sides. Basically just move it, 3/5 x. Add that to both sides, and I get 3/5 x plus y equals 11/5. Alright, so you might say that's standard form, but it's not exactly because of these restrictions. A, B, and C all have to be integers, but right now I have a couple of them that are fractions, right? So to deal with that, we clear the fractions. We multiply by the LCD, which the least common denominator of all the fractions in the problem, which the only denominator is 5. So if we multiply both sides by 5, which is perfectly legal to do, multiply both sides of the equation by 5, I distribute the 5 on the left. 5 times 3/5 is just 3, so we get 3x. 5 times y is 5y. And 5 times 11/5 is just 11. And now we have standard form. And that's what we were asked to do. A lot of times they'll ask you to find standard form because you have to work your way through point-slope form, slope-intercept form, and then we get to standard form. This other restriction, a has to be greater than or equal to 0, we're okay here because it is, right? This a value is a positive number. It's a non-negative number for sure. So this is our standard form. If this were negative, it would be a simple adjustment. We just multiply everything in the equation by -1. Alright, let's look at the next one. We're going to go through the same process. Again, it might be a good time to pause and try to do one on your own. Follow this process and see if you can do it. And then check to see if your work matches what I do. Alright, so let's look at this one. I'm going to start again with point-slope form. This again is my x1, this is my y1. So we have y minus a -7, which is y plus 7, equals our m, which is 4/3, times the quantity x minus -4, which is x plus 4. Alright, so that's point-slope form. I like to go then to slope-intercept form. So I'm going to distribute the 4/3. So this is 4/3 x. 4/3 times 4 is 16/3. And again, you can use your calculator if that helps. So we have y plus 7 equals this stuff. I'm going to get y by itself and really move to slope-intercept form. So I'm going to subtract 7 from both sides. And so this becomes, let's see, y is equal to 4/3 x. And 16/3 minus 7. Okay, again, you could do that on your calculator, but 7 is really 21/3, right? 7 times 3 is 21, so 21/3. And let's see, 16 minus 21 would be, what, -5, so minus 5/3. Now I'm going to check just to make sure. Check my calculator. Let's see, we have 16/3 minus 7, and we'll make sure we get the right thing here. See, that says it gives me a mixed number, right? And I hit second, ABC, just to make sure my math is good, a -5/3. All right. So here we are in slope-intercept form. If we want to get to standard form, I need to move the 4/3 x to the other side. I've got to get all my x's and y's on one side. So I'm going to subtract 4/3 x. So then I get -4/3 x plus y equals -5/3. And this is almost in standard form, but standard form requires we have integers everywhere, right? So we can't have fractions, which means I need to clear the fractions. Now I could multiply by 3, but notice there's a negative here for my coefficient of x. And we don't really want to have a negative there. So I'm going to multiply both sides not by 3, but by -3. So multiply both sides by -3, and then see what we get. -3 times -4/3 would just be 4. -3 times y, that's a -3y. -3 times -5/3 would give me a +5. And then we have our standard form. Again, we went from point slope to slope intercept. Finally, we got to standard form. And that would be my answer in standard form. Alright, we have one more of these to do on this page. Let's again, it might be a good time to pause and see if you could do this yourself. I'm going to go through this one kind of quickly. So point slope, y minus 2 equals 2/3 times the quantity x minus -1, which is x plus 1. I'm going to distribute the 2/3, so I have y minus 2 equals 2/3 x plus 2/3. I'm going to move everything to, I'm going to move the x, I'm going to add the 2, get y by itself, add the 2 to both sides. So I have y equals 2/3 x. 2 is really 6/3, 6/3 and 2/3, that gives me 8/3. Right? So I have point slope form, I have slope intercept form. I'm going to move all my x's and y's on one side, so I subtract the 2/3 x from both sides. And I'll go back up here. So I get negative 2/3 x plus y equals 8/3. Now I need standard form, which requires these be integers. Since this coefficient here is a negative, I'm going to not multiply by 3, but by negative 3 on both sides. And then I get negative 3 times negative 2/3 is just 2x here, and then negative 3 times y is minus 3y, and negative 3 times 8/3 is a minus 8. And that's my standard form. 2x minus 3y equals negative 8. And that would be my standard form. Alright, so those are some good examples of finding equations of lines if you're giving a slope and a point. And all the different forms of an equation of a line are represented as we work through these problems. Okay, I'm going to stop this video here and we'll continue on the next page.